Hey guys, this is Jeff with the local constructor, and today we are sitting with the post tension guy himself, Deel of Constress Incorporated. And so I get asked a lot about post tension. There's a lot of confusion. I guess overall, a lot of ignorance in the world about post tension because it's not well known in common terms. So we've got Lewis to come in here today, and hopefully, we're going to enlighten you and um, educate you. So thanks for coming in.
I'm
Um,
glad to.
so we'll just jump right into it. So post tension, people act as though they heard about it yesterday. How long has post tension been around?
Well, in the construction industry, uh, back in the early 60s is when it really started developing in the United States. Uh, the story or the version that I've heard is back during World War II. It, uh, it was a shortage of metal. So the French needed to build bridges and other structures, but all the metal was going to tanks and bullets and ammunition, and the government said, "Well, you're just going to have to build bridges and structures with less." So it was a French idea that was developed at that time to structurally create spans by putting concrete in compression using less metal or steel at the time. Now, of course, it has evolved over the years since some of the early designs. And in the United States, in the early 60s, it was basically used in a lot of commercial applications.
The French. That's surprising. I didn't expect that. I think that's the first I've ever heard that.
Really?
So they gave us toast and cakes.
Coffee.
Wow. All right. So you're with a local company here in the central Mississippi area, Constress. So about how long has Constress been involved in it?
Well, Constress incorporated in 1954. Uh,
So
obviously,
since the beginning.
yeah, well, here again, it was more into some of the commercial stuff. Uh, of course, I was not present at that time, but that's when the company started, and it has evolved just like any other industry there. I came to work with Constress in the late 70s, 79, 80, and have been there since.
So, if you had to sum up post tension in a nutshell, somebody comes up and says, "Hey, what is post tension and how does it work?" Just general purpose.
Well, Constress, I mean, post tensioning is a means of putting concrete in compression. And concrete in compression is the best building material you can get. In tension, it's kind of worthless. So the ability to put concrete in compression is what post tension does. Uh, and depending on the application for it, whether it's in high rise structures or slab on grades, the design criteria is different for each method, uh, depending on what you're building.
You have two main types of foundations here. You're going to have either post tension or you're going to have a rebar or steel slab. Um, how would you compare post tension versus steel?
Well, both systems are effectively good design systems if they're designed correctly. Um, Typically, rebar is considered a passive reinforcing system. It really doesn't kick in to do anything until the bond strength of the concrete's yielded to either forces of expansion or settlement. And then it relies on this.
So, in layman's terms, it doesn't start working until a problem starts happening.
Well, yeah, I guess you could say that. And it relies on the friction of the concrete against the bar and the stiffness of the bar to resist it. Where here again, as I said earlier, post tensioning is a means to putting the concrete in compression. So it's considered an active reinforcing system. It's working in conjunction with the strength of the concrete to create your structural member. It's not waiting for something else to happen. Uh, and here again, both systems are effective if designed correctly.
Um, are there soil conditions going on that would make post tension favorable over a steel slab, or vice versa?
Well, early on, particularly if you're talking about the residential market, uh, it was kind of advantageous to use in expansive soils because the slab had flexible qualities to it.
And when you say expansive soils,
Well, in this area, we're particularly talking about Yazoo clay. That's, in the central part of Mississippi. As you get into the other parts of the state, it's different types of. The Delta has a different type of clay material up there that has different characteristics. But in Mississippi, in the central part, everybody calls it Yazoo clay. And of course, with Yazoo clay, as it absorbs water, it expands, and as it loses water or dries, it shrinks and contracts. So when you have a foundation setting in Yazoo clay, it's going to tend to heave as it gets wet seasonally and shrink and deflect down as it dries. So you could have literally an up and down movement seasonally.
So it's kind of like you've set your slab on top of a heartbeat.
Yeah, well, one of the examples they used to use was a popsicle stick. If you had a popsicle stick in your hand, you kind of bent it back and forth all the time. In expansive clays, that's what would literally happen with a foundation slab. With the concrete being in compression with the post-tension system, it had memory to it. It could withstand that constant flexing up and down and maintain its structural integrity. So, but in today's construction world, particularly in the residential market, you really don't have quite an issue with expansive clays because of code requirements and site preparation. Typically, it's recommended that you have some type of buffer or fill material over any expansive soils. That's the reason you see on some areas, if you go out there and see where they've dug a big hole in the ground and start bringing in a fill material, it's to create that buffer against expansive soils.
So your post tension slab, you're going to have these cables running in multiple directions, going everywhere, from end to end. Is there a limit on how long a cable can go? Is there a cable that's too long, and is there a cable that's too short?
Well, if in factual, you can a tendon length could be really an infinitesimal number depending on the structural application that you're using it for. Now, when you say how long can a tendon be, you have to have specified distances between stressing points on the slab. In other words, in our designs, we typically use generically about 100 feet as a guide to determine we need to have a stress point on each end of the tendon at that point. Now, the tendon can be continuous, like if you're doing, example, a tennis court where you have 240 feet runs, you have an intermediate stressing joint and then a final stressing joint. So the tendon can be 270 feet long or more, but you have to have intermediate stressing points. Now, as it applies to the residential market, here again, most structures are, even if you're at 150 feet or something like that, you can compensate for that distance by adding more tendons and increasing the compression ratio in the concrete. So it's kind of it has to be specific to the design and the purpose. Now, as far as the shortness of a tendon, generally, the shorter the tendon is, the less elongation or stress forces that you can get to it to maintain it. So we generally try to stay in about a 10 to 15 foot range, and even at that short range, you have to really have a lot of additional tendons to have an equivalence in compression in the concrete.
So, kind of circling back to a word that you just mentioned, intermediate stressing joints. So, let me get this understanding right. So, you're saying back to the tennis court, we've got a cable that's going to be too long to tension in one pull. So, we need to have multiple pulls on that single cable. So, it's installed, then concrete is poured, then it is stressed, and then it is poured again. Is that what's happening?
This is subsequential pour, the next pour, yes.
So basically, you're locking two slabs together with one
Right,
tendon.
right. It's still a continuous operation of the tendons are tying the slabs together, but just due to some engineering terminology, friction created by the length of the tendon and everything, you need to have an intermediate stressing point to make sure you get the proper compression on concrete, because that's what post tension does. You're putting a specific amount of known compression on a volume of concrete. So to achieve that, you have to have these intermediate points.
So in theory, if I wanted to build an entire highway, this cable could stretch forever as long as I just do it in sections.
Yeah.
So we just go and go and go and
Yeah,
go.
well,
Just keep repeating the process.
yeah. In theory, yes. You'd have to find a manufacturer that could manufacture
Well,
a
just ask the
strand.
French.
Yeah, well, 10 miles of strand, continuous strand. But
Is there a particular type of design that has to go in for a post tension slab versus any other form of slab?
well, it is designed specifically for a post tension slab.
Now,
Here
do you
again,
design the slab, or is it somebody bringing the slab a plan to you and
no,
you're
we
installing it?
we have our own engineering department. We actually take and specifically we'll discuss the residential market. The owner or architect or design firm supplies us with a plan, and we'll take that plan and design a foundation for that individual structure. In residential construction, it's so many different sizes, shapes, and appearances and height. It's not a cookie cutter one design fits all. You have to design the foundation for that specific project or house or what have you. So yes, it's designed by us individually.
So once I get your design now, as far as the application of the foundation out in the field, are there things going in my foundation as far as how it's constructed? Does it change in any way? So if I'm doing a steel slab and I'm going out there and just digging some footings and putting up some forms, and is there anything that has to be done differently because it is a post tension slab?
Well, as compared to a rebar design, because most rebar designs have your interior footings or grade beams located under load bearing walls. In a post tension system, load bearing walls are not necessarily the specific points of design because you're trying to create more of a grid or a waffle pattern. So your footings will be more uniform. It won't be a lot of little chopped up footings here and there. It's going to be a continuous footing or grade beam from one side of the structure to the other.
And that's mainly due to because you're trying to get a cable from point A to point B.
Well, yes, true, but not necessary. It has to do with when we're designing, you try to take advantage of the shape of the structure. Here again, houses have wings and extensions sticking off in different directions, or the L patterns and what have you. So you're trying to use a degree of uniformity in your footing detail to tie these together. And uh, when you put concrete in compression, it really kind of distributes its load carrying capacity. So unless it's a what they call a concentrated load or something like that with a steel column or something like that, your footings are going to be more of a web design or a waffle design if you want to use something simplistic.
So everything is about time and money. And okay, so I go and I'm having a house designed. I've had to wait all this time to get my house designed, and now I've got to get it to you for post tension foundation design. how long how long does that process take? Kind of, is there a generic turnaround time on how much longer is this going to take?
Yes, yes, it is. I mean, in general terms, we tell most of our clients that to figure about a week from the time we receive the plans to get them turned around, depending on how complex the plan is. And it's just like any other industry, depending on our workload at that time. Uh, and sometimes we can get them out in 2 or 3 days if if stars line up, kind of stuff. But we generally tell most people to figure about a week to get them back.
So the if I say I've waited long enough, I've got I've got my plans. I'm eager. I'm ready to go. Can anybody just design my post tension foundation? Can I just, hey, I've got my foundation plans. I've got a foundation plan that came. I bought these offline, and they've got it came with a foundation plan. Can we just use that, or how does that work? Can I design my own post tension plan, and you just go out there and put it in?
You need to have a good working knowledge of how post tension works and how it works in the particular application or design that you're doing with. And so you need a design professional, I guess, related to an architect or home designer. Do you want to design your own home plan? Figure out where all the framing and all that kind of goes to. So, no, not if you expect the end product to perform like you want it to perform. You need to have somebody professionally design it, whether it's Constress or an independent engineering firm or whoever that is in this industry.
Well, we've mainly been talking about post tension in residential foundations. Are there any other applications that post tension is used for outside of home construction?
Oh, yes. I mean, initially, post tensioning systems were used in the commercial or high rise markets, or I've seen it, like I said, used in water tanks, uh, retaining walls, even bridge girders. They have a similar system. It's a different design criteria, but a lot of these bridge girders and stuff you see moving, they're called a pre-stress girder, which is kind of a similar theoretical idea. But most high-rise structures today use some type of post-tension system, and it's all kinds of advantages to it, such as spanning between column supports. It generally takes less concrete because the individual floor slabs are thinner, it doesn't require as thick of members. And like I said, over the years, we've been involved in some projects where, like I said, water tanks or here again, a similar system was roof structures overhanging football and baseball stadiums and stuff like that.
Thinking about these high rise buildings. So I go, say, you show up to the hospital and you pull up in the parking garages. Are those the same type of cables at, that are these barriers? Is that the same type?
Well, yes, it's a similar type. It here again serves a different purpose, and generally the barrier cables are what they call they're exposed. They don't have a grease coating or any plastic coating. A lot of them don't. Some of them do, uh, but it serves a different purpose. But it's very similar. The strand is generally identified by the diameter of the cable itself or the strand itself, and they make what they call anything from an eighth inch to 6/10 diameter strand. The most common strand used in construction is the half inch or zero point 0.5 diameter strand. Uh, Generally, in the residential market, particularly, it's the most common size used. But now the parking garage itself is probably post tension also, not just the barrier cables. Here again, we're talking about the slabs where or the floors where you're parking your cars on. They're all post tension designs. I think you would be hard pressed to find particularly many parking garages that don't use the post tension system.
If I go with a post tension slab, for my house, you're talking about the compressions. So I'll just ask the question that most everybody would like to know: if using post tension, is it more economical in my dirt work? Can I cheat the system and do less if I'm getting more from my concrete?
No, that's kind of a statement, not generic in phase, but any foundation, regardless of whether it's rebar or post tension, is only going to perform as well as the soil supporting the foundation and how that soil is maintained through the life of the structure. Uh, we talked earlier about expansive clays. Well, most people don't build on expansive clays. We discussed earlier how it's excavated out or some type of buffer is created between it. But when you're dealing with select fill materials, they need to be placed properly also. It's a specific method of putting select fill in lifts and compacting and testing every lift through the entire thickness of.
And you're referring to dirt.
Yeah, dirt. Yeah, when you're talking about fill material, it's some type of dirt that's non-expansive, depending on what's available in your particular area as to what you use. But here again, just because you put fill on a site and build a house, that's not going to eliminate any consolidation or compression in the soil by the weight of the building if that soil is not packed properly. Site preparation is the most critical part of your whole foundation design. Everything else is just structural additives to it that create a slab or a foundation that will last for the life of the structure. And that's what you're looking for. You're making a big investment in your home. I kind of loosely say if economics makes a lot of choices, particularly in residential construction, you can always add a chandelier later on pretty economically. So don't cut corners in your foundation. From the site preparation to the reinforcing method to the design criteria all the way up, use a professional to do this work and make sure it's done professionally. That's what you're looking for, and you'll get the product that you want.
So can I combine steel and post tension? Can I get the best of both worlds all in one slab?
You can to some degree. It's not, here again, you were talking about cost. Well, it's what we call the cost to benefit ratio. By adding both systems in, are you going to get enough benefit to warrant the expense that goes with it? Probably not. But here again, it's possible. It's certain design criteria that may be a requirement. Like I said, that you're generally talking about elevated slabs in those situations. But we've seen projects where they would use like wire mesh or something included in the post tension system to try to minimize shrinkage cracks. Concrete is guaranteed to do two things: shrink or get hard and develop shrinkage cracks. So here again, you start getting in economic decisions whether you get a cost to benefit ratio.
Your company is located in central Mississippi.
Yes.
So if I lived in Georgia and I want post tension at my house, how do I how do I get a hold of you and say, hey guys, get on out here and come do my house?
Well, typically we will travel that far, but generally your cost gets a little prohibitive. So it's possibly someone in your area, if you live in Georgia, that's in a similar line of work, that it may be more economically feasible for you to check with a local supplier. We try to stay local. We do travel, as you know. From Jackson, we've gone to Little Rock to do specific jobs, or the coast, or anywhere in the state of Mississippi. We have, like I said, ventured outside some, but it's generally, you start getting into the economics or the cost for us to travel that far.
So it's a case that there may be somebody closer.
Yes, yes. I would probably tend to, if somebody called me from your example of Georgia, I'd say, well, let's see if we can find somebody local that can help you, that's more familiar not only with your area, but the soil conditions in your area and all the other code requirements for your specific area. So,
but at the end of the day, if you're willing to pay, we're willing to drive.
yeah, in some cases, yeah, I'd say we would.
Okay, so well, for people here in local Mississippi, um, how do they get a hold of you?
Well, our office is located, we're at 2655 River Hills Drive, which is near Ridgewood and Lakeland Drive in Jackson. The office number is 601-922-6673. My mobile number is 601-331-0874. And our email address is pretty simplistic. It's constressinc@yahoo.com. That's CONSTRESSINC @yahoo.com. We'd be glad to help you with any post tension needs that you have, and just give us a call.
Well, Lewis, I really appreciate you taking the time to come in and sit down today. I know y'all stay pretty busy, so really appreciate it. And guys, we hope you enjoyed the video and hope you get some education out of it, learn something maybe you're curious about. If you have any questions, feel free to hit us up. And as always, go subscribe. Thank y'all.